Hello, I'm Professor Gibson. Welcome to a teaching video about Chapter 7, Section 3. My video about 7.2, the questions I used were mostly p-values, so this time we have two kind of lengthy examples. They're both going to be rejection region method, all right? So I've written the key numbers out to the left here. Let's just jump in. A used car dealer says that the mean price of a 3-year-old sports utility vehicle is $21,000, right? So that's our mean right out here. The mean of the claim. You suspect this claim is incorrect and find that a random sample of 21, there's our N, similar vehicles has a mean price of 21,843, right? So there's the mean of the sample. The claim is always considered the mean of the population. And a standard deviation of 1934, right? So they're telling you right now that this 1934 is of the sample, which is why it's S. And that's also why we're going to end up using the t-distribution, because the only standard deviation we have is of the sample, not the population. Is there enough evidence to reject the claim at alpha equals 0.05? We got that out there too. All right, so the first thing, as typical, is to find the null and alternative hypotheses. This is one of the ways MyLabs Plus does it. They give you 6 different pairs to choose from. Let's do it. So the claim is 21,000, right? So we've got to find the null and the alternative, right? So that's equal to, right? So the claim is that the mean equals 21,000. Well, equal to means that one's the null. The complement of equal to is not equal to. Make your note that that the claim is the null. All right, and if you look at the different pairs, this one would start here. That's the right answer. All right, find the critical values and identify the rejection regions. That tells us right now this is going to be a rejection region method. I'm not sure why, but when MyLabs Plus does this, when they ask for the critical values in the rejection region, they usually have you find them before you find the test statistic. When they do p-value method, usually find the test statistic first. So anyway, so before we find that, we need to help. What kind of tail of what's the tail of the test? Well, that comes from the alternative, right? It's not equal to, which means it's two-tailed. Okay, so we're going to skip over the standardized test statistic for now, and we need to calculate the critical value. Well, it's two-tailed. Here's the method. Except that all of these, if you'll notice, they all say norm and normal, right? So when it's a normal test, this is what we use, but this one is a t-value, right? Because we have the standard deviation of the sample, not the statistic. So everywhere in this section where it says norm or normal, insert t, all right? So right here, two-tailed, we're going to do plus and minus I and VT. So I and VT, it's two-tailed. So if you're right there for two-tailed, you do alpha over 2. So 0.05 over 2. Now then you remember when you do when you do t, the other thing you put in here is the degrees of freedom. Since n was 21, the degrees of freedom is 20. All right. And then this is going to get us negative 2.086. And then since this was two-tailed, the other one will be 2.086. Okay. Next, determine the rejection region. So when you've got a negative and a positive, the rejection region is the region where if the test statistic falls in the rejection region, we're going to reject the null. So it's always the areas further away from 0. All right. So for negative 2.086, it's going to be less than negative 2.086. For 2.086, it's going to be greater than, because those are the areas that are further away from 0 than these two critical values. All right, so there's my rejection region. Next, I got to find the test statistic. All right. It's really the same formula. When we're doing a hypothesis test or a claim about the mean, it's always the same formula, right? So we'll do x bar, which is 21,843, minus the claim, right? X bar minus the mean from the claim, 21,000, divided by the standard deviation is 1934. divided by the square root of the sample size, which is 21. Do that calculation, you get this number here, 2.00, right? 2.00. Okay, so we have now worked our way through. We've come all the way down through 5. Step 6. The next step is to make a decision about the null hypothesis. The question now, when we're doing the rejection region method, is the test statistic in the rejection region or not? Well, see, it's 2.0. The rejection region is either less than negative 2.086. Well, this is positive. It's not over there. Or greater than 2.086. Well, 2 is close to that, right? But it's not greater than that, right? It's less than that. So our test statistic is not in the rejection region. It's not in, right? And that's why this one is the answer. It's not in, so we're going to fail to reject because the test statistic is not in the rejection region. All right, last step, make a decision about the claim. Go back up and remind ourselves, the claim was the null, and we just failed to reject the null. All right. So that means since the claim matches the null and we failed to reject the null, we're essentially going to fail to reject the claim. The key wording for that when you have this situation is there is not enough, or sometimes there is not sufficient evidence to reject the claim. Now, they have a little bit different wordings. They'll always have this core part in it. Sometimes they'll say stuff about the level of significance will be in there. Sometimes they'll have stuff about the claim, which is what they do here. This one ends up being the answer at the 5% level of significance, because that was what we did for this question. There is not sufficient evidence to reject the claim. See, there's our key wording. That the mean price is $21,000. Okay, so there's our first one. Okay, so let's do our next example here. Again, I've written all the key numbers out to the side. Test a claim that the mean amount of lead in the air is, here's our claim, less than 0.035 micrograms per cubic meter. All right. It was found that the mean amount of lead in the air for the random sample of 55, there's our sample size, is 0.038. And the standard deviation from the sample was 0.068. At the alpha equals 0.01 level, can the claim be supported? Okay, so first thing we need to do is the null and the alternative, right? HO and HA. This time the claim is less than 0.035. Well, there's no equality in there, right? It doesn't say less than or equal to, it says less than. So that's going to be the alternative. And then the null then will be the complement of less than, which is greater than. And this right here is another way that MyLabs Plus will do that. You see, it gives you separate boxes to pick each of these symbols. And as you can see, that matches the null alternative we just picked. And they have a thing here, the claim is the alternative, right? So this was the claim right here. Now, next again, find the critical values. Find the critical values and identify the rejection region. So first we have to determine the tail. Tail comes off the alternative. It's less than, so it's left-tailed. Okay. And again, because the way MyLabs Plus does these, we're going to skip over the standardized test statistic for now and find the rejection region. Again, we didn't know the standard deviation of the population, so everywhere you see norm or normal in this, and stick in T, we're going to find the left-tailed rejection region. When it's left-tailed or right-tailed, we just put in alpha instead of alpha over 2. So I and VT, the alpha is 0.01. The degrees of freedom, see the sample size is 55, so the degrees of freedom is 54. And you put this together, and out will come negative 2.4. Okay, and this is left-tailed, that's negative, that's all good. Now, they want you this time to pick the diagram that matches. Okay, so remember the rejection region is left-tailed, so it's going to be less than this number. So we want the graph that has our t less than minus 2.40, or our shaded region, right? Here's the one that's less than. So there's our answer. All right. Next step, find the standardized test statistic. Again, this is a question about a claim about the mean, so it's the same format here. Okay. So what we're going to do is we're going to do, so x bar is 0.038 minus the mu of 0.035, right? The mean of the sample minus the mean from the claim over the standard deviation is 0.068 divided by the square root of the sample size. Okay, do that calculation, and it is going to come out to be this 0.33. Okay, so we've worked our way through the first 5 steps. It's now time to do step 6, either reject, make a decision, if you will, about the null hypothesis. So the question is our test statistic in the rejection region? Well, our test statistic is positive 0.33, right? Well, our rejection region is not anything less than negative 2. So our test statistic's like right here. It's not even close to being in the rejection region, right? I want you to notice something. Even though the rejection, it was left-tailed and the rejection region was negative and all that, it's perfectly okay for the test statistic to be positive. It doesn't have to match, okay? So it's not in the rejection region, we're failing to reject, okay? Now this time, if you remember, we were, the claim matches the alternative here, right here. We failed to reject the null, which, loosely is kind of accepting the null, right? So we can't accept the alternative. So the key word for that is there is not enough evidence to support the claim. Okay? So we get down here, look at what's happening. This is another way they do this. These are all drop-down boxes, okay? If you look, here's our key phrase. Again, they're going to put other information in there. They'll have they have more information about the claim in there again. They'll have the information about the level of significance. Make sure you copy those correctly from the question. All right. There is not enough evidence, right? We picked the is not enough evidence at the 1% level. That was what the level of significance was. Copy that correctly. To support, right? Not enough evidence to support the claim that the mean amount of lead in the U.S. cities is, and then here was the claim, less than 0.035. All right, that is it. I hope you found that helpful.